So it's me again. So I put a picture of Denver, the last dinosaur, which you may know if you are born before 1985. Because, well, 3 years ago there was an entire session about content steering. 2 years ago there was 3 papers. Last year, 2 papers, 3 papers, and I think I'm the last content steering paper this year, so I'm the last dinosaur somehow. Not mock as well. So it's something we are talking about content steering, but not multi-CDN, and how we can use it for many other features that we want to have for the delivery. So first I will back on content steering. So in content steering, the clients request manifest, and in this manifest they have a steering server URL, and they will go to this steering server. Each client will go to the steering server and say, what is the best CDN now? Or what is the best pathway, actually? And the steering server will reply, use this pathway alpha in priority and come back to me in 60 seconds or in 30 seconds or something like this, which means that it's possible to instruct each client to get the data from one specific pathway, actually, so CDN. What we realize is that it's not mandatory to have multiple CDN in the pathway. We can actually create some virtualized CDN, so, which all points to the same infrastructure, right? And the steering server is something which can be plugged to or can be connected somehow to the delivery infrastructure. So this is something that Sean McCarthy mentioned during the panel before, that you need to have in SVTA some metadata to instruct, to let the third-party server to know what's happening in the CDN side. And it will be very helpful to drive the steering server decisions. So steering server decision is usually which CDN you choose, but it's not mandatory. And we also realize that the process, usually we can have some information that will also be useful for the steering server to decide what to do based on the information of the encoder or the packager or some other kind of information coming from somewhere else. So we see the steering server as a dynamic coordinator of a delivery platform, which is very good because it is in touch with every customer and every consumer of the content every minute, so or every 30 seconds if you want, or every 2 minutes if you want. And this is good because it is aware of delivery infrastructure and aware of the processing infrastructures. So it's something which is a very powerful tool if we think about it. And we can use it for much more than just disaster recovery from multi-CDN. So first of all, so here I have a multivariant playlist, which is good. And so typically what we can do is that we can define, I don't know if there is a pointer here. Oh yeah. We define the steering server, we define some group of audio, and we define all the profiles for the video for the pathway CDN A, and for the pathway CDN B, oops, we did not send the top profiles. And so in that case, according to the discussion we had with HLS, Dash has another view of it, but there is some convergence about it. If the client is instructed to go to the CDN B, it will, even if it has the bandwidth to get the highest profile from CDN A, it will stick to CDN B, and so it will not get the top profile. Okay. And so why it would be good? Well, somehow you can have premium plans in the mobile world, so you have premium users and regular users. So if they are in their home, they use Wi-Fi, they can use all the profiles. If they go mobile, if you are not a premium one, you just get skipped for the 4K profile. That is not super cool, but it's something which is actually a request. Sometimes you have CDN which have capacity problems in some areas. So they have a group of servers which does not, can no longer deliver everything. So it's a way to degrade the quality for everyone in the area without having some problem in the CDN. And you can also have prime time quality. So you can say, well, I will use the 4K profile only when it is a Super Bowl, but when it is the wildlife documentary at 3 a.m., you can just get rid of this specific stuff. So it's one way which is easy and to implement something which is necessary, I would say. You have this observation that in the live TV channels, we switch from one game to one old series, to some news, to some talk shows, and all of them, they have different profiles, they have different quality, different encoders, settings, different ways to implement this. So it's known as a content-aware encoding. So people have been discussing this for a while. So the problem is that if you open your TV at the beginning, you have the multivariant playlist, which cannot be changed, right? So if you want to change this information, you need to trick something. You need to send data which does not correspond to the original multivariant playlist. So here you have a very easy solution. That's you have the manifest creators, and you have the encoders and the CDN. And here, if you say, okay, I will create at the beginning different pathway. So here is typically sports and cartoon with different settings and different ways to prepare the content. And if you are able to have a timeline map that will fix the information, you will know that during the 2 first hours you have a sport, and then the next 2 hours you have a cartoon, and again you can switch from one configuration of the playlist to another configuration of your playlist, and this is done without any tricks on the content-aware encoding. So it's basically based on some guidelines that you may have between the encoders and the steering servers, or some program guides, or some SCSI markers that you can have. So these are the example of it. In the paper that we have, that will be in the proceedings, so it's something which is expected in 2-3 weeks, right? We discuss another use case, which is edge switching. So sometimes in the CDN, you need to shut down some servers because you need some maintenance, because you have some poor performance, or because simply you want to have dynamic infrastructure management. You want to reduce your software. Or another one is that you have clients which move, and so you attach initially this client to one group, and you want to attach this client to another group later. Okay, and the problem is that this server that you want to shut down, it has a lot of sessions which are attached to it, right? And you need to migrate these guys. And this requires some coordination between the edge servers, between the CDN gateway, the network entities which are involved into the mapping between the client and the servers, and with the video clients. And in practice, it's something which is complicated because, as discussed during the panel, DNS management at the client side is very unpredictable. They have like a TTL caching and a lot of different parameters that make that if you want to change DNS management of this, it's complicated in practice. HTTP redirection is even worse. Manifest manipulation is hard to scale because here you need to give very specific information so that you can move someone from one server to another. And if you consider the layer 4 load balancers mechanism that can exist, you cannot move from one data center to another. I mean, you need to stick to some IP address, and so you need to stick to some area, and so which does not fit with the client's network change. So how does it work in practice? We receive the ACDN instruction, we go to the DNS, we receive an information, which is this edge server number 1 is the one that will serve you, right? And so you got the final answer for this, and you get the manifest. This is the way we map today the people. So we have this wonderful screenshot from the paper for the drawing, which says, well, we can have here a control plane system which receives telemetry information from the traffic router, which is a gateway for the CDN, the edge server 1 and edge server 2, and from this, it can decide that we need to switch. Okay, we need to switch from edge server 1 to edge server 2. And when we want to switch, we first say to the traffic router, to the gateway, if you receive any information about this client here, you will switch it to the edge server 2. Okay? And then you send this to the content steering server. So content steering servers know that this particular client with a specific ID should be changed from the current mapping that it has. Okay, and so here you have two ways to do it. You can create a clone of this CDN. So you say, hey, you were in alpha, which is a CDN. Basically, we have only one CDN, so it's super easy. And then we say, okay, now you will use alpha. You will use beta, but beta will be the same CDN, but with a different subprefix, which means that this will trigger a new call to the DNS or a new call to the router. And the same with this. This is another way to implement it. You define basically a CDN and a B CDN, and if you want to force some new mapping between the client and the edge, you simply flip the pathway. Okay, so it can be used for A/B testing as well, but at least it is something that is super easy to implement. So, takeaway, because I will be quicker than the 15 minutes. The content steering is a key standard for multi-CDN because it allows midstream switching. So it's something which is high demand. It offers flexibility in the multi-CDN orchestration, but it can be used for more than just multi-CDN. Even if you have one CDN, you have multiple scenarios for using based on the distribution problem that you have or based on the processing problem that you have. We have a lot of some annoyances somehow because of the DLS cache and user instructions that are hard to pass, and with the content steering systems you can have a clean way to simply orchestrate all of this together. Thank you.
Thanks, Wendell. Okay, quick question. So for support of the approach described here, is there any standardization needed?
Well, content steering is standardized. So I mean it's standardized.
So basically, you're describing an approach based on existing standards.
Yeah.
Okay.
So here I can say a word. Initially it came from Apple, which was not really open standards. Now they have released content steering as IETF standard, but no working group behind. So if you want to discuss this draft, you need to talk to Apple. And Dash has defined content steering in ETSI, which is another standard group. And the decision was taken to kind of merge both content steering draft into the IETF draft from Apple. And if you want to contribute to the content steering systems, typically with these kind of scenarios, you can just write emails on the Apple interest groups.
Got it. Thank you. Any more questions? One or two? Good. Seems it's pretty clear. Okay.
Thank you.
No more questions. Thank you.
Good.
Thanks all the presenters.